Okay, well, welcome to the webinar. So I am Matt Cederberg. I'm the Coreform CEO, and I'm coming to you from my basement in Lehi, Utah. The other presenters today are Randy Morris, who's calling from his office in Payson, Utah, and Carl Merkley. So Randy's the COO and our channel manager at Coreform. Carl Merkley's the product manager of Coreform Cubit and a senior engineer, and he is calling in from his home in Cincinnati, Ohio. So welcome. I can see some of you from around the world as well. So it's good to be together. So the agenda that we're going to follow today, there'll be two parts. First, we're just going to briefly introduce Coreform. And then for the bulk of the webinar, we'll be introducing Coreform Cubit. And specifically, Randy will go ahead and walk us through using the hex meshing procedure to make a simple part. So Coreform LLC, this year we're the fastest growing CAE company on the Inc. 5000. We were established in 2016. We acquired CSumSoft last year, and they were the co-developers along with Sandia of Trellis, or the Cubit software. We're headquartered in Orem, Utah, but with COVID, we've gone fully remote, and now all of our hires ever since COVID hit have been across the country and Europe as well. So the software that we're developing at Coreform, strategically, everything that we invest in is to help customers develop safer products faster through better math. So this is what attracted us to the Cubit software and why we made that acquisition. In our opinion, Cubit is the premier hex and tet mesher in the industry. It especially shines for advanced meshing for challenging simulations. The reason why we acquired that is because it's the perfect front end for the Coreform IGA finite element solver that we are developing, and we just barely released that to some of our close partners earlier this month. It's a isogeometric analysis solver for highly accurate and fast solutions for nonlinear structural response. So we'll be having more additional webinars in the coming months introducing Coreform IGA, and that's something that we're also really excited about at Coreform. One thing we wanted to especially mention before Randy starts is that engaging with the community really matters to us at Coreform. So we have a number of ways that we do that. One is through the form on our website. We also there host a number of tutorials, including in-depth Coreform 100 or Cubit 100 and 200 level courses that we've gotten along with information from Sandia, and also a series of webinars that we'll be doing monthly. We have a Coreform YouTube channel that's fairly new, so please subscribe if you haven't seen that yet. And with that, I'm about to turn it over to Randy. Just a little bit of housekeeping first. If you're new to the Zoom webinar as well, one thing we like to do here is take advantage of the back channel chat. So both Carl and I will be on the line. We can address any of the questions that you can ask at any time over chat. We'll either type them back directly or we'll go ahead and cut in so Randy can address that during his demonstration. This webinar is being recorded. And with that, again, thanks for being here, and I'll turn the time over to Randy Morris.
All right, thanks, Matt. It's good to be here in our morning. Some of you are up late or up early. And thanks so much. We always have choices we make on how we use our time, and we're honored to think that you're using your time this next hour to learn a little bit more about Cubit. Cubit is today we're going to focus on the hex meshing workflow. There are other workflows available all in Cubit, but we're going to focus on hex meshing. It's been under constant development since the mid-1990s. Some of you know the history, some of you do not, but it's a code that is well tested, not without bugs. There's so many cases out there, but it's been employed and deployed in many challenging situations throughout the world. We've been involved, Carl and I, with CSumSoft, and elemental technologies since, well, for almost 20 years, well, more than 20 years now. And Sandia's Cubit predates that. So we're going to talk about hex meshing. One of the questions is, though, what's the difference between hex meshing and tet meshing? What are the trade-offs? I mean, Cubit was developed first for hex meshing. As you might remember, the original paving algorithm was developed by Ted Blacker and Mike Stevenson back in the 90s. From that came their hex meshing algorithms. But also we employ and license from Distine, which is a Dassault company, their tet mesher and their triangle meshers. We also have our own triangle meshers, and we consider our tet meshing to be world-class also. That's important to know. We do focus on hex meshing in this webinar, but it's a world-class tet mesher also. But Carl, did you want to take just a minute and talk about hexes versus tets, the trade-offs, value versus the other? Could you do that just for a moment?
So just for a moment there, and my video is still apparently off, but that's okay. You can imagine what I look like. Hex meshing versus tet meshing really depends on the physics of your problem. So as an analyst, you really need to understand what is going on with your problem. You need to understand your physics. People ask me about this from time to time. I say, I'm not the domain expert in your domain. You are. You tell me, what are your requirements? Tet meshing has the advantage of it's very fast, very easy to create a model. The downside is for certain kinds of problems, the results are not as accurate. If you're doing highly nonlinear problems, if you're doing dynamic problems, if you really need a very accurate mesh and a very accurate result, then you need the best mesh, and a hexahedral mesh will give that result. I think that's all I got, Randy.
All right, that's good. That's a nice overview. So let's get into this. Cubit think. That's a little term we've coined. There's a lot of really good meshers out there in the world. A lot of you use other meshers. We like to think Cubit can be used just about anywhere. We've had a lot of success with it. It's very strong in some domains, probably not as strong in some other domains. But regardless, there's a workflow that we use in Cubit that might be slightly different than workflows you're used to. So really the purpose of this webinar is to talk about that workflow. And we call it Cubit Think. The workflow is this. As we import solid models, simplify geometry, and decompose geometry, steps 2 and 3 are where we will focus today. And within those steps, there's a particular workflow that is most effective. Step number 4, imprint and merge, is something that we'll talk about a little bit. It makes Cubit somewhat unique in that it is a specific part of the workflow that we need to do by hand. It's a little bit different than other codes possibly. There's some good reasons for this, for having step 4. Other workflows, there's good reasons for that too, but this is the way Cubit likes to do things. Step 4, so 2, 3, and 4 really are where we're going to focus our attention. And once we've got the model ready to go, setting schemes and intervals and meshing is actually quite simple. So let's go ahead and look at these learning objectives. We're going to take this, you saw that model at the beginning we call knuckle. We'll see it on the next slide. We're going to mesh that knuckle using 2 different workflows. One of them will be using sort of our standard power tools, commands from the command panels and the command line, and a few things like that, sort of the normal way of doing things. The other way is going to be using the item wizard, which is a user-directed wizard. It is really, really good for new users and intermittent users. In other words, if you're not meshing all of the time, you mesh a few times a year, item might be really, really effective for you. Or if you're brand new, it might be a good way to learn the workflow. So this first method is the command line and power tools. And so let's go ahead and dig in. If I'm set up properly here. Here we go, hang on. All right, this is live Cubit. I've got this going, and I'm going to go through this workflow with you. And again, if you've got questions, go ahead and post those to the chat channel. Carl will interrupt me, Matt might interrupt me. Carl is officially doing what we call color commentary. In other words, if I misspeak or say something that actually isn't correct, Carl will, he's commanded and asked to correct that for us so we can be clear. All right, so here we go. I'm going to go ahead and import that model. I'm going to go up to File menu. Obviously, I've got it in my recent imports. Go over there, grab this guy. That's what we call knuckle. And it's a very interesting little thing. It's not going to be automatically hex meshed because there's some issues that we'll talk about here just in a moment. Not only in terms of defeaturing, but just in the terms of how do you actually put a continuous hex mesh on something that looks like this. It's got holes, it's got these blends down here, it's got this cylinder up here with a hole through it, it's got some interesting features along there. All of these make hex meshing challenging. We've got this tiny little surface. Let me show this little surface right here. That little guy there. This little guy up here at the top. These are all challenging things. If you think about putting hex elements in something that looks like that little small surface around there, that might not be effective. Anyway, those are the things that we learn about. So let's do this. So I am in what we call the geometry, the diagnose geometry power tool. I got that by clicking on this tab at the bottom. See if I'm on the bottom right. These are our command panels, the power tools, an item. We'll get to item in a bit. Back at power tools on the first one, and I am going to do something here. I am going to, first of all, let's do this actually. Let's go to the mesh power tool, and I'm going to say, look at all the volumes in my model. I could narrow this down to specific volumes. In this case, we only have one volume. I'm going to click Analyze, and it tells me something interesting right off the bat. It tells me volume 1 is not meshable. It says no scheme set. That means Cubit can't automatically put a hex mesh on this model. If I expand this out a little bit here, what's interesting is this. It did find good algorithms for all of the surfaces, but it can't do it in a way that makes it hex meshable. Let's talk about this just for a second. Let's click on surface 1. It says that should be paved. Let's click on this surface over here though. Surface 4 is a pave. Surface 23 is a pave. Surface 6 is a pave. That's interesting because how we usually do this is when we do hex meshing, we're looking for surfaces that we can pave. That's a quad mesh. And then we sweep from a source to a target through the part, and the linking surfaces have to be mapped. So in this particular case, if somehow I wanted to pave this surface, and that would be required, right? Because I've got this hole, I can't put a map, I can't put a regular grid on this surface. It needs to be paved. And and I can look at that just as an analyst and say, well, that's gotta be the source. Maybe the target's over here. It's got to sweep through this direction, which means this surface needs to be mapped. Cubit's saying, no, only way I can think about that surface right now is pave. So that is giving me some clues of how I need to treat this model, right? And in a subsequent step here, we're going to isolate some of these parts by cutting them and making smaller volumes that can be paved and then swept, right? So in the end, I'll cut things here so that this surface can be paved, this surface can be paved, and this surface right here, which is a linking surface, as well as this one down here, can be mapped, right? It has to be that case. So anyway, let's go back to this tool.
So a map surface then, Randy, is one that just has 4 sides with no holes inside. Is that right?
That's right. So yeah, when we look at a surface to be mapped, we have logically 4 sides. Doesn't have to be an actual rectangle or a square with 90-degree angles, but logically 4 sides, and we can put a nice regular mapped grid in there. That's right.
Great.
Yeah, thank you. So back at this tool, I'm going to do this. I'm going to click Show Solutions. So for some of you who have used Trellis or Cubit for a while, this is version 2020.2, which we released about 2 weeks ago. This is a new feature in this tool, so Show Solutions. The old version of the tool just did this. We're going to click on this, which for you who have been around for a while recognize this as an item-like interface. I'm going to go ahead and click Auto Update. So as I make changes here in a minute, you'll see why I do that. And I'm going to click Analyze. So I've given it a small curve threshold of 1 as an experiment. That means that's the size of the mesh element size that I consider to be small. Any feature smaller than 1 will be flagged as a potential issue, right? That makes sense, right? So if I've got a curve that's shorter than 1, and remember, Cubit is unitless, so 1 is just relative to this model. So if I have a curve that's smaller than 1, and I've said I don't want to put a mesh element smaller than 1 in this model, this will be flagged as a feature that we need to address. So I'll hit Analyze, and it tells me some interesting things here. It tells me that I've got some badly defined curves. I've got some bad vertex angles, and I've got at least one blend chain that it doesn't like, this guy right up here. So let me say a word about this. We do our best to flag features that might be problematic. We don't pretend to think that we can find every single feature that's a problem, and we don't pretend to think that any solution we might offer is the right solution. So we really depend on analysts being in the loop here. This is simply a way to give you some ideas of why does Cubit think it can't put an automatic hex mesh on this thing. So you can say, aha, that is interesting up there, isn't that? I ought to go take a look and investigate and see if there's something I can do. When we have things like badly defined curves or badly defined surfaces or whatever, one thing we recommend is always doing this. When we import a model, and Carl, correct me if I'm wrong, we want to run what we call an auto healer. Our solid model kernel is from Spatial. It's the ASYS kernel. Spatial also is owned by Dassault now, and they have a healer kernel in their solid modeler that will look at these badly defined curves. It's ASYS that told me these curves are badly defined, and ASYS can do some things to clean them up. The metaphor for this tool is this. As I click on problematic areas, this is actually being updated down here. It's given me ideas of things that I might do. In this particular case, I know that if I click on Auto Heal Volume 1, it will give me a preview of what the model will look like if I actually run this command. In this case, there's not a lot of information. It just highlights the volume and say, well, at least you're still going to have a volume. That's a win for everybody. So there's not a lot of information there. But then if I right click with my mouse, you can see that I can execute that command. I could also go down to this command panel. The ... implies if I click on here, which I'm going to do, it takes me over to the command panels, to the heal command panel for volumes. So if I were doing this on my own, I click on volume, geometry, volume, modify. The pull down here for modify includes heal. volume 1 is selected, I would select auto heal and then hit apply. If I go back to my power tools, I've got this still selected, right click again. I'll just go ahead and execute that from here. So it will generate the command to run auto heal on this volume. As I do this, because I've got auto update selected up here, and you'll see a little dialog that pops up that says something like, these are all the checks and the tests that we're running. We'll see this change up here. And with any luck, these badly defined curves will all go away. So let's see if we can do that. So execute, it's done, they're gone. And that's how we use that particular thing. So I like that a lot. I'm looking at this model though, thinking that I don't exactly love the answers that I'm getting. If I click on these up here, vertex 2, clearly there's an issue down there, right, with those surfaces. I don't like those at all. I can't put a good hex mesh in there. Down here, as I'm clicking on these things, it is giving me some ideas of what might be, what I might do. There's blunt tangency commands, there's collapsing angle commands, there's compositing surfaces 1 and 23. If I click on that, for instance, to say, well, we could do this. We could take this surface up here and this surface right here and make them one surface. Well, no, that's a terrible idea. Let's not do that, right? Again, we're just trying to give you ideas of things that you might do as an analyst. In this particular case, I don't like these things. So I'm gonna select in the out there so that highlight goes away. Let's look at this for just a moment here. We have this idea of removing surface 15. So we got this blend chain. And it says remove surface 15. Surface 15 is that little guy right there. I right-clicked draw. And that's how I saw that. To get my graphics back, I clicked that little guy up there. But I'm seeing that as a surface that is problematic. It says I can just remove it. So if I click on that and then right-click, execute, it's going to generate this command down here. So my eyes now are down on the command line. It just generated remove surface 15 extend. And now that particular issue has gone away with regards to that blend chain. But I still got this problem down here, this little guy down there. I know I want to get rid of him. So let me turn that off right there so I stop highlighting the volume. I'm going to do something here. I'm going to change the small curve threshold to something a little bit smaller. I'm going to go to 0.5 and see. I didn't want to do that. Sorry, hit auto. It's something different. 0.5, analyze, and I've got this surface down there. Now, this has been defined as a close loop. Again, these terms aren't that important, but what it's telling me is that the curve for the loop around this surface right here and the curve for this surface right here are very close. Well, they're very, very close, right? So I know this. I do know I want to get rid of that. So if I click on that guy right there, it says one thing I can do is remove surface 17. In this case, I'm going to right click again. Let's go to the command panel this time. And you can see that the command is going to be similar to the other one. We're going to issue a surface 17, remove, the extend option is on by default. And if I preview that, which we're already doing, we'll see that we're going to get this model. Again, the preview is somewhat useful. What it tells me is it's not going to do anything terrible to my model. It'll be mostly intact. And I'm going to hit apply this time and go back to the power tool. I'm going to analyze it again. And it tells me surface 18 is a closed loop. Well, I know something about this model, and I know as an analyst in this case that I'm going to ignore that. It's not actually going to be a problem because I know how I'm going to attack the decomposition of this part. So I'm going to leave that alone. Again, it's a false positive. I don't have to act on it. There's nothing here that I want to do. We could remove it. That seems like a horrible idea, right? Let's not remove surface 18. Let's not composite 18 and 19 or any of those things. And let's just move on. So the next step in this thing is to decompose it. And the way that I'm going to do that is we have a term in Cubit called web cut. I believe, Carl, is that a term that's sort of unique to Cubit?
That is a term that is unique to Cubit.
No one really knows where it came from. There's a urban legend that back in the day, someone at Sandia was looking at an I-beam. So an I-beam would be a piece of steel like this and a piece of steel like this, right? You'd beam up a ceiling or use it in some other structural situation. And they wanted to separate the top plate from this thing, which happens to be called in English a web. And they came up for a way to cut that, remove this from here, separate these two, turn this one volume into two volumes, right? Volume 1, volume 2, and that was called web cut. I might have just made that story up. I don't know. I've heard that though, and I'm sticking with it.
It is a good urban legend.
That's a good legend. So we'll do this. We're going to go to the command panel now, and we're going to go back here to geometry, volume, this pair of scissors for cutting. and I want to cut this volume up. Now, as I'm looking at this, as we talked about before, I know a couple of things. I know that I have to put a paved mesh on this surface and on this surface, because I have to do something with those holes. I could, if my analysis didn't need these two holes, I could easily remove them, right? But in this particular case, I know I want to have those holes. So I've got to do that. So I know I've got to pave from here to here, and I know this has to be a linking surface. So in order to do that, I'm going to isolate this part and this part from this part up here by cutting along these curves right here. You can see these curves. We zoom in a little bit. I've got that little curve right there. Let me just highlight him. I've got that curve there. I've got that curve there. These are going to be good places for me to cut. And there's a number of ways that I could actually do that. I'm going to use a particular web cut method here for purposes of the demo. And I'm going to go down and find one called plane from curve. Another way to label this is plane normal from curve. You'll see the command when I execute it actually has the keyword normal in it. So here we go. I want to select volume 1, and I want to select this curve as my target curve, and I want to cut it that normal, and I'm going to show you something here now. I'm going to do one from the start. Let's see what that looks like. I'm going to hit preview. Let me say this about command panels. Nothing happens real until you hit apply. The state of the model will not change until you hit apply and actually issue that command. You can see down here at the bottom, we did issue a command, web cut volume 1 with plane, normal to curve 33, fraction 1 from the start, but we added the preview keyword, which means all we're going to do is show you graphically what's going to happen. In this particular case, I really like that cut. That tells me if I execute this command, I'm going to isolate this piece down here, this piece down here. I get a 2-for-1 kind of a cut, and I'm going to do that. So let's go ahead and apply that cut. And now I've got these volumes. I'm going to go back to my power tools for a moment here to this guy, and I'm going to change this to all, select analyze, and look at this. Volume 2 is now sweepable. Volume 3 is now sweepable. If we were to look at the surfaces, we can see surface 24, this little guy up here, is going to be mapped. That's a linking surface on the other side, right? That's going to be mapped. This is what we would expect to see. even inside those holes, those will be mapped surfaces. And then these outside things here will be paved just the way we would expect for that particular volume. So let's go back to the command panel. That was a nice little check. And it tells me this, that volume still is not ready to be meshed. I cannot pave and sweep that. I don't have anything that looks like it's going to work. I'd like to sort of pave these surfaces at the top and then sweep those all the way down to this here, because I can do that very nicely. But these little blends in here are going to cause a problem. So let's isolate those. We'll continue going. So go back to the command panel. We're going to select that volume, and we're going to select that curve again in this particular case. But this time we're going to do something zero. Let's change this to 0. We'll use that. And so that's telling me this, that I'm from the start of this curve. So that apparently tells me that this particular curve 33 starts right there. I'm at 0 fraction from the beginning of that curve. And I'm going to make this cut normal to that curve at that location. That's what that's telling me. If I were to change this to 1 and hit preview, hang on, I clean that out. It would do this again, which is not useful. I'm just trying to show you how I use this fraction right there. If I go back to 0 and do a preview, or if I had change this to end, it would do that, right? So the command I want is cutting volume 1 at curve 3, normal to that, 0 distance from the start of that curve. I'll hit apply. Let's go back here quickly, hit analyze on all volumes. And now I've got that one, and that little guy ready to go too, right? So we've got map surfaces there. We're going to pave that surface. We're going to pave this surface. Sorry about those. Do this different. Pave this surface, and all of these other surfaces, as you can see, the linking surfaces will be mapped. It's exactly what I would expect, including that little guy down there. That's logically four-sided, so we can map it. So let's go back then and cut this guy. Or are we on time? Well, we're doing fine. And let's look at this volume. Again, this time we want to select this curve right there. And fraction 0. I don't know if that's the start or the beginning. Let's do a preview. So I don't want that. So let's just change that to the end then and do a preview. That's a good cut. I'll do that. I'll go back to my little power tool, select all, hit analyze, and now I don't have any that I can't mesh, and all these volumes now are meshable. So if we remember that little flow chart, which probably we don't, although I'll post these slides later, we have now defeatured. We took those 2 small surfaces off the top of this cylinder, and at the bottom of the cylinder, we have decomposed the volume so that we have sub-volumes that are pave and sweepable. You can see they are legitimate volumes in our model tree over here, right? The next step, though, is what, Carl? Can you remind us what the next step is?
If I unmute myself, you can. The next step is to go ahead and imprint and merge so that we make sure that we have one continuous volume when we're going through and.
So what is imprint, Carl, and what is merge? How do we think about those?
So imprint essentially takes the image of the curve of the surfaces and maps those across the boundaries. So if I have 2 surfaces that have features that interlap, imprint will map all of those surfaces onto the same surface. In this case, they're really simple because there's only boundary curves. We don't have any internal curves in this, which is a good thing. It makes life simpler. In general, when you're trying to do these web cuts, look for cuts that will create mapped, or what we call submappable, which are rectangular surfaces that are kind of combined together. Imagine taking two pieces, taking a cardboard box and unfolding it. All of those pieces individually are mappable, so the whole thing is submappable. So you want to make cuts that will do that. When we do the imprint and merge, we take the curves, map them from surface to surface, and then we merge those surfaces so they're shared between the two volumes. That's what merging is, share those surfaces.
And this is the step that is a little bit unusual for new Cubit users. Other tools might do this. They have to do the same thing, right? Effectively, however they do that. In this particular case, we make it an explicit step. If these were just contact surfaces and there was slippage that I wanted to analyze, then I wouldn't merge, right? So I'd want those two surfaces to stay separate, and because I put boundary conditions on them, analyze them for contact. In this particular case, we're analyzing effectively this one overall knuckle, this one volume, by merging these 5 volumes together. In the end, you'll see we still have 5 volumes, right? We still have volumes 1 through 5, but they will be imprinted and merged so that we can put a continuous mesh on the knuckle. So the way I do that is this. I'm back to geometry, volume, over here, this little icon, imprint and merge volumes. And I can select this one right here. Now, Carl, is it true in this particular case? In this particular case, because these curves are all external on the boundaries, we don't actually have to imprint, right?
That is exactly correct.
Yeah, that's important. Carl did mention that. We don't have to. We will. It doesn't hurt anything. Typically, but you wouldn't necessarily have to. It's a good practice to do so. Most cases you will. So in this case, I'm going to select all, and I'm going to hit apply. It's nothing much to do. The command is merge volume all. We issued 2 commands, imprint volume all, merge volume all. We can see that down here on the history tab. These are all the commands we've issued so far today. We keep doing these volume all scheme auto to see if things will mesh. And imprint volume all, undo, and then merge volume all, undo. Undo just means that we've added these commands to an undo stack. If I went up here, I could click undo and it'll undo that last operation. We won't do that. So this is ready to go. So the next step is now simply to go and set my interval sizes, so my element sizes for the mesh, and let it do its thing. In this particular case, well, let me get there. So we'll go to mesh, volume, over on the left, setting intervals, automatic sizing. I'm going to select all. And as I move this little slider here, you can see an estimate of where the intervals will actually be set. This is not exact, but it's very, very close. I'm going to apply that size. And in this particular case, all I have to do is hit the mesh button. And there we are. So there's my mesh for that particular part. You can see easily now, we've got paved meshes over here. We've got in these surfaces right here, clearly mapped, right? You can see that now, mapped. Here we pave from this surface to this surface, and mapping surfaces are the linking surfaces in between. And on this one here, it's interesting because we can see that we have a paved surface up here, on this surface right here, on these surfaces right here, and they sweep all the way through. And if I go like this, looky there, you can see actually, maybe that's an instance, Carl, where we actually did need to do the imprint. No, that's not true. But we can see the outline for this curve that's running along the bottom of the cylinder that's actually made its way all the way through this. That's exactly what we'd expect when we are paving from several sources down to one target. We would see this mesh propagated through. Anything you wanted to say about that, Carl, in particular?
No, I think you've nailed it.
I nailed it. Let's see if it's any good. So now we'll go over here to this determine mesh quality. I'm going to select volume all again. The default metric here is shape. We've got some defaults to show a graphical summary, to draw the mesh elements. I'll hit apply. And it tells me that the lowest quality element, which are these down here, has a shape metric of 0.3. We consider anything above 0.2 to be good. Your simulation might say that's not good, and so you might want to do something different down here to refine that to get better quality elements. If we change it to something like scale Jacobian, I'll hit apply again. We can see that the lowest scale Jacobian is 0.285. Again, same area, we would expect that. And in our world, most of our worlds, that is a sufficient quality. If we were to follow through on the workflow at this point, we would go ahead and set up for, well, we might go ahead and add material blocks, side sets, node sets. Those are terminologies that we use in Cubit too. We're not going to do that today. We'd set up the boundary conditions, and we go ahead and set up an export. All of these steps are relatively straightforward, and some codes will accept those boundary conditions, blocks, side sets, and node sets. The boundary conditions associated with them, we can set up, force and pressure and heat flux and temperature, a bunch of CFD boundary conditions. Some codes just have you export the mesh directly into them and set up all the boundary conditions there. So that's a typical scenario at Sandia, where they set up the boundary conditions in their simulation codes. All right, let me flip back to my little presentation here. I can get to it. Oh, I'm looking at the wrong thing. Goodness gracious, Randy, there we go. All right. Let's look at method number 2, item. It's an acronym for Immersive Topology Environment for Meshing. Also a funny story, but we won't get into that. So this is a wizard-like tool that is going to take me as a new user or me as an intermittent user through this workflow. I'll go through it a little bit more quickly. So I just want to really give you the idea. The commands that will be generated will be the same, and the workflow will be the same, but this is going to give you more of a guidance. It will automatically imprint and merge for you, again, because it's typically used by new users or intermittent users, and we found out that one of the most common mistakes in using Cubit for new users is forgetting to imprint and merge and wondering why I don't have this continuous mesh. So in item, we do that for you. And it's a wizard, but it is easy to exit the tool, get right back in where you started. So it isn't one of those tools that forces you down a particular path and you can't get out until the end. It's a little more interactive than that. So we'll go ahead and dive into that then. And we're going to start by simply, I'm going to go up here to the top left where it says new. I'll click new. That issues a reset command, by the way. I'm going to go ahead and close all this. I'm going to go over to item. And this is the workflow from top to bottom. This list of tasks. We import geometry, we set up the model, we prepare the geometry, we mesh it, we validate it, we define boundary conditions, and then we export it. Well, that's fairly straightforward. Once we get into a couple of these places, it'll give us even more detail. So I'm just going to click on, I can click on the button, I can click on this, it doesn't make any difference, they're the same. I'll click on that and it tells me this. As a new user, you can do a few things. You can open a Cubit file, you can import a CAD model, you can build your own geometry. So Cubit allows you to build from primitives like cubes and toruses and frustrums and spheres and all these things, or you can build from the vertex up. We've got many, many users in Asia, in Japan in particular, who love this for building. They build their geometry from vertices, curves, to surfaces, to volumes, and they do it all inside of Cubit. We don't consider Cubit a real CAD tool, but it does have all those capabilities, so you can do those things. In this particular case, we're going to import a CAD model. Again, in our simple metaphor here, we say, well, import an ASIS model or a STEP model or an IGES model. Obviously, we can import lots of different model types, including native CATIA, Creo, SolidWorks, Parasolid, all of those things, right? They're all available with an add-on import module. In this particular case, we want to get that knuckle model again, and there we go. So it opens up now, it finally opened up a sort of standard dialog. I'll go down here and look for my little buddy knuckle, the most analyzed piece of geometry on Earth, at least in our world. And there we go. So there's knuckle again. And when I'm done with this step, I click done. And I click done. Think of these pages as on a stack, and I'm just hitting the back button. So there we go. Now I want to set the model up. And this is interesting because I can tell Cubit, hey, I'm either doing a hex model, a hex mesh, or a tet mesh. And then some of the guidance it gives you will be tuned towards hex meshing or tet meshing. Some of the sizing suggestions will be tuned for hex meshing or tet meshing. Obviously, we can put triangles and tets in smaller areas than we can with hexes, well-formed hex in tiny areas, right? So there's some trade-off there. In our case, we'll stick with hex. I'm gonna grab this little guy down there and start moving it again. It's the same sort of thing we saw before, which shown me where my intervals might be. But it's doing this. It's telling me what the approximate number of hex elements I'm gonna generate and or the approximate size of those elements. In other words, you could come in here and say, I've actually got an element budget of N. You can put that number in there. We'll do that. Let's say your element budget happens to be 6,000 or 8,000. I hit apply, and it changes all of this and shows me what the mesh is going to look like for that. And this, I don't want to do that. I'm just going to go back to here, and I drag this around, get back to my 4,000 element deal. I don't have to hit apply. It's already set it. I'm going to click on done. And now I'm going to dive into prepare geometry where it's more interesting. So you'll notice there's a lot of words in here too. So there's a lot of in your face sort of obvious help to help guide you through this process. I'm going to run check diagnostic, check meaning these, right? I can uncheck these. Maybe I don't want to ever look at connect volumes, those issues. And by default, everything's checked. So I'll run check diagnostics, shows me a little progress over here. And then it says, looky, you've got 3 areas of problems with this model that you ought to investigate. Again, could be some false positives, but it says you ought to investigate. We suggest this. These are laid out in a particular order from top to bottom. We suggest the first thing you do is fix invalid topology, and then remove small features, and then do connect volumes, and then build the meshable topology. And as we click in here, we'll see what these things mean. We believe this, that if you do things in this particular order, you'll minimize side effects of defeaturing, right? We know that when we defeature, sometimes it creates additional problems. We're trying to minimize that. So understanding this workflow is going to help you, even if you're an experienced user, going back here and seeing, oh yeah, I want to do these things in this order, it's going to be most effective. I'm going to speed up a little bit now because we're nearly out of time. I'm trying to keep this to about an hour. So I'm going to click on fix invalid topology, and it tells me again, I've got badly defined curves, same things we saw before. This tells me to choose automatically repaired problems and let Cubit attempt to automatically correct the problem. So I'm going to do that. And it did it, and it did another analysis, and those problems are gone. I'm going to click done. I come back, and this is now marked okay. I'm going to dive in to remove small features, and I'm going to look at this. So in this particular case, Cubit set up this small curve length. I know that's too small for what I want to do. I want to do something more similar to the first example that we did. This is an interesting thing. I'm not going to do it now. You could dive into another dialogue here to actually look at your 10 smallest features in the model and decide for yourself, I wonder what my threshold is for small. Set that threshold and let Cubit then analyze the model based on a threshold that you actually set based on good data you've got from the model. That's your homework. Push this 3-button thingy right here and go look at that. I'm going to change this to 1. And I'm going to click detect small features. And I get this list here. This is slightly different than I even saw with that other power tool, which tells me a few things that are interesting, but we won't go into that either. There's surface 17, surface 15, surface 1, and surface 18. So again, if you, as I'm clicking on this, you can see this is changing down here. It's that same metaphor of giving me a potential problem, possible solutions. And if I don't like those solutions, this is static information here. These are other things you can do related to narrow surfaces or small features that you might want to do. I could, if I click on this, I go to the tweak offset command in Cubit. So we're just trying to give you a little guidance if you're brand new, or where can I go if I don't like any of those things? Well, I can go into surface modify. Tweak is a really powerful set of commands, and there's all of these options here. That's a good one to learn, right? I'm going to go back to item. I'm going to go ahead, select surface 17. I've got this execute button. Remove surface 17. I'll go ahead and do that. This has been updated up here, surface 15, remove surface 15. I'm going to execute that. I look at this one, surface 18. Again, I'm going to ignore it. I can just move on right now, or I can do this clever little thing and say, actually mark as okay. That was a right click, mark as okay. And when I click done and go back, even though it typically, Cubit still thinks it might be a problem, it doesn't show up here. I'm not sure that's that valuable, somewhat helpful. Let's go in here. And again, we have this situation where we can check meshability. It says volume 1 is not meshable. I can do all of these things. In this case, I don't have any blends to worry about, but I do have volumes that I need to decompose, right? So I'll go ahead and click here. And again, it runs that same thing. I click on that and it starts giving me suggestions. Looky, Carl on the call wrote this, what, 10 years ago, Carl?
Yeah, but just remember that those are suggestions, and I didn't have any machine learning going on 10 years ago to help me to determine which one should be selected. So
yes,
I need a man in the loop, person in the loop to figure that one out.
That is right. And so I've selected with my mouse this particular one. If I hit the down arrow, I'm just hitting down arrow, I get all of these interesting solutions, right? Well, we can see from our last example, some of them are pretty darn good. Some of them aren't. It's a heuristic Carl used. And again, as Carl said, they're not necessarily the right answer, but they might be. So in this particular case, I'm going to go ahead and select that one. Actually, I'm not. I'm going to go down to that guy and select that. I can right click, execute, or hit the execute button. And there we go. This updates, so 2 and 3 are meshable, 1 is not. Let's see what it wants to tell us now. We got something like that. I like that one, so I'll go ahead, execute. Now these 3 are meshable, this one is not. And same thing. I'll go ahead and click execute on that. And now all are meshable, so I can click done. And I can click done. And I noticed this yesterday, we're getting a false reading right here still. It says there's still a problem. Well, we know there's not, because we are really good at meshing and we've finished this. So I'm going to click done. That gets me out of prepared geometry. Now I'm going to come into mesh. I'm going to give it all. I'm going to say generate the mesh. It said, we're good. There's all my things. If there were a problem meshing, I'd get some errors down here with some possible solutions. I will tell you, this is the weakest part of the tool. There aren't a lot of good solutions if it won't mesh. It isn't always entirely clear at all. why not? You'll need to look again at the model, and as an analyst, try to make some determinations there. But that one's good, so I'll click done. Now I want to validate the mesh. Here I have the opportunity to select the metric I want. We'll select this. In this particular case, this is interesting, it's different. I can actually set from here the minimum and maximum values for the shape metric. I'm going to leave them alone, but I can make a change. I can do that for any of these, obviously, right? As we go down here, you can see these values. So I'll leave shape the way they are. I'll set done. I'll say check the mesh quality. Again, select all, analyze quality, and it tells me that my worst hexes are right there. I just highlighted that one, but the threshold is 0.29, so I'm okay. I can delete the element. If you're a thermal kind of an analyst, deleting elements is a valid thing to do. I can do some additional smoothing. I might do a local Laplacian smooth. If I hit execute on that, I can do that. Let's see if anything changed. So now we're doing, we actually did a little bit better. That local Laplacian smooth actually made the model better. So that's nice. We're almost out of time. Let me just do this. I'm clicking done. If we go into define BCs, this is a little bit less of hand holding. If I click on define blocks, it just simply takes me now to the command panels to define blocks, side sets, node sets, material properties, those kinds of things, right? If I come back here and click on define BCs, this is the same thing. It's just going to take me to the command panels. I'm going back to item. I click done, export mesh. Again, a very simple dialog. I can generate a Genesis mesh, an Abacus mesh. These 5 or 6 we thought that were the most interesting or the most commonly used. And then I could click export mesh. It'll give me the dialog. I'd give it a name. And it says it's already there, and finish, and there we go. So that is that. Let me flip back to, unless there's something, Carl, you wanted to add, I'm going to flip back to the presentation.
I think that's good.
Just quickly as we sort of wind up here, don't forget to imprint and merge. Dirty geometry is an issue, right? Cubit is ASIS based. So we import SAT files and SAB files. That's the binary form of an ASIS file natively. And we don't typically have dirty geometry. But if you're importing from Creo, the tolerance is different, which might mean vertices and things which normally in ASIS would be coincident or merged or whatever, won't be necessarily in another solid model. So that's where the dirty geometry is coming from. Step files can be extremely dirty, right? Other files are dirty. So we recommend healing the geometry when you import it, especially if it's not a native ASIS file. And again, the tweak and WebCut commands are probably the most commonly used for defeaturing and for preparing the model for hex meshing. So on our website, you can see we've got more webinars coming up. Curtis Ford from Sandia National Labs is going to conduct a Coreform masterclass. Curtis is a master Cubit modeler. He's been an analyst at Sandia for years. He'll be conducting a seminar in January. Carl on the call will have one in January, and Greg Vernon, another product manager here at Coreform, will talk about IGA. So that will be sort of one of the first public discussions of isogeometric analysis, the Coreform IGA simulation product. Recommend joining those. All of these are recorded, so if you're in a time zone that's difficult, you can always get them later on our YouTube site. So Matt, that's it for me at the top of the hour. Any burning questions out there in Cyberland?
Well, Randy, first of all, thank you so much for your excellent explanation. I think you pulled out a lot of what we like so much about Cubit in there, and that it's so straightforward to use and it's very precise and clear. So thank you.
You're welcome.
Thanks everyone for attending. I'm happy to stay on the line with Randy for a couple of minutes if there's any questions coming in. Yeah, it looks like we've got a comment. Go ahead, Carl.
No, I was going to go ahead and say we had a comment from Anatoly as to why don't we just do a TEP mesh and then convert those TEP meshes. You can take every TEP element and convert it into hexahedra. So that's a simple problem. Why don't we just go ahead and create hexahedral mesh that way? The problem is you cannot guarantee high quality mesh out of a T-hex, a tetrahedra to hexahedral mesh. And especially when we're looking for these really high quality solutions, then the hexes, those kinds of hexes really don't buy us a lot. So in that case, you're right, Anatoly, subdividing the model is kind of like a geometry quiz. There's a little bit of an art to that problem, but it does give us the best quality mesh for a lot of different kinds of problems.
Great, thanks, Carl. There's another good question that came in. It looks like, can you auto hex mesh based on mesh quality criteria?
So for that question, I answered that one to Pirkan just directly in the chat. But during our meshing process, we actually go through and do smoothing and readjust the mesh to the best that we can with the given geometry. But we don't have a given way that says create mesh of this quality or better, but we are automatically doing that with the given geometry.
Thanks, Carl.
Good question. That's an interesting question. Yeah. So is Anatoly's. Anatoly, one of my favorite humans on the planet. I like Anatoly.
I do have a question. If Mila Khan, if you are on, would you raise your hand?
Raise your hand. That's a pretty advanced thing to ask someone to do.
That may be an advanced ask. Or send something in the chat that says that yes, you are here. Mila had a question about handling STL files, and I may just have to answer.
Go ahead and answer it, Carl, because she probably will look at the recording and she'll, or he, I don't know if Mila is a he or she. I'm sorry, Mila.
I don't either.
Yeah.
Let's see. Can I share my screen, Randy? Yes, let's see. I think I can.
I'll stop sharing mine.
Okay, let me share my screen.
Boy, we're really jumping off into the deep end now for our webinar here a minute.
We are jumping off into helping users solve problems here. Okay.
And what was the problem, Carl? What is Mila seeing?
Okay, so I'll show you what the problem is here. All right, I've got a little journal file off on the side here that I'm just going to run that will help me. I'm going to just step through this. We'll start with a brand new problem, and we're going to import an STL file. And I'm actually going to import that STL file with the option to make all the elements. Now, when this comes in, I have mine set up so that every volume comes in as a different color. So all of these actually come in from the STL file. That's a volume, but if I draw this, right click and draw, it's really just a surface. And that's an anomaly of the STL file. If I go ahead and look in the STL file, I have a body that's defined here, that's defined by all of these triangle facets. And I have multiple bodies defining this. So the fact that I have multiple bodies means when I bring them in, I create them as separate volumes. So in order to work around that, we're not smart enough actually. We don't deal a lot with STL files. That's not our major focus. So we're not smart enough just to know, oh, this should have been one complete volume, even though STL told me it was multiple. So what we're going to do is I'm going to write this out again, and I'm going to export it. And I'm going to say, export this all, triangle all. I just want to put all the triangles out, and I want to export it as a single volume. So I'm going to go ahead and play that line. Export STL sample 2.stl try all. I'm giving it the overwrite flag because I've run this several times already. I'm going to reset and read this back in. And now all those volumes are colored as one volume instead of having these things come out. If I click on this volume now, I select the entire thing. If I come down here and say my scheme is tap mesh, I can just mesh this volume immediately.
Oh, that's nice.
So it's partly understanding what's going on with the STL file and understanding that, oh, that's what happens, and that we are not smart enough to recognize that formed a closed body because the STL file didn't tell me it was a closed body.
And is that a typical STL workflow, Carl, or is this unusual?
That's a little bit unusual, but it's not that unusual that STL just says put every surface out into a separate body.
So you brought that in, because it reported those things as what we call sheet bodies, right? The
Yes.
0 volume bodies. And we know we can't make a closed volume from those. We can't mesh it as a volume. You exported all the triangles as a volume, or you exported all the triangles, you read it back in, and then we are smart enough to make a volume out of that, right?
Exactly.
Yeah, okay, cool.
So let's look, we have one other question, and then we probably better close the webinar, and we'd love to engage with everyone else more on forum.coreform.com with any other questions that you have. This one's from Dustin. Are there tutorials on improving the mesh quality? It seems simplifying the CAD geometry is the best way, but are there tools on top of that?
Oh, yes. Tools for, so say that again, Matt.
Are there any tutorials available for improving mesh quality?
Yeah. Are you able to share your screen, Matt?
Yeah.
Go to the Coreform website, and we added all of those tutorials that Sandia wrote onto the website last night. There's many. So go to support and tutorials down at the bottom. There we go. And if you click on step-by-step tutorials, it takes you down to the bottom of the page, and then see those PowerPoint tutorials down there?
Mm-hmm.
Many, many. So those are, we have a link for all of them zipped, lectures 1 to 26 slide decks and models and slide decks, and then each individual one. So Dustin, this is the training that Sandia offers, that we have offered in the past, actually paid training. And there's a lot of topics covered in here, including all these things you just mentioned. So we recommend diving into some of these, they're PowerPoints. The sample models are also around on the site you can download. And I think this is a wealth of information, especially as you get into those higher numbered lectures. Quite detailed. And that's how we train up our power users at Sandia and other places. So good question.
Great. Okay. Well, good. Well, thanks again, everyone, for showing up. It's nice to engage with everyone, and look forward to seeing you more on the forum and the future webinars. Thanks.
Bye, everybody.
Bye.
Bye.